So what I'm going to do in this video is I'm going to show you how a molecular compound actually exists, the shape that it assumes, and in order to do that, what we're going to create are Lewis dot diagrams. Now there are specific rules that you need to follow and that I will need to see when you complete homework or quizzes or any sort of work with Lewis dot diagrams. And the following are your rules. So C, the first thing that you need to do is you need to count your valence electrons. Okay. So for example, if I give you H2O, which is the first example, hydrogen has one valence electron. However, there are two hydrogens, and then oxygen has 6 valence electrons. Remember, as you count across, it's 1, 2, 3, 4, 5, 6, 7, 8 for the noble gases. And so if I add these together, I have 8 valence electrons. So I'm going to leave that to the side. I'm going to ignore it for right now, and I'm going to move on to my second rule. My second rule is S. S, I need to share valence electrons. Okay. So all I'm going to do is I'm going to take the single atom that I have, which is oxygen, and I'm going to share electrons with hydrogen, and I'm going to share electrons with the other hydrogen. Okay? The next rule that you need to do is L, which is lone pairs of electrons. Okay. Every atom for this class, except for hydrogen, needs 8 valence electrons. Hydrogen only needs 2 valence electrons, okay? And so here, each line, because we are sharing electrons, this is 2 electrons right here. Each line represents 2 electrons. So if you think about it, hydrogen has 2 electrons already. And so it's fine because it only needs 2 valence electrons. All the other atoms need 8. And so oxygen right now has these 2. It has these 2, and so it only has 4 right now, so it's going to need 4 more. So I'm going to put 2 here, and notice I say pairs of electrons. So you put electrons together, you don't separate them, and 2 there. Okay? Now my very last step is I need to count valence electrons again. Valence electrons again. Okay, so I want to only use 8 valence electrons, so let's make sure I'm only doing that. I've got 2 here, so 2, 4, 6, 8, and I'm good to go. Alright, so let's look really quickly, because when we took this water molecule, so this is what you should draw where it says Lewis dot diagram without model kit. When you actually create this, it doesn't look like that, it actually looks like this. And the reason why is because these 2 pairs of electrons are actually going to push down on this bond right here, creating a bent shape. And so on a quiz or test, I don't want you to draw it like this. I want you to draw it like this. And so if you're concerned, as soon as you draw a Lewis dot diagram like this, go grab a molecular model kit, and that will help you to draw it properly like that, because you can't make it incorrectly with the model kit. Alright, so I'm going to do the next problem. Okay, it is CCl4. Okay, so I'm going to follow my rules. So the first thing I'm going to do is I'm going to count valence electrons. Well, carbon has 4 valence electrons. Chlorine has 7, but there are 4 chlorines. So that's a total of 32 valence electrons I'm going to want to use. I'm now going to share electrons. So I'm going to have 4 chlorines coming off of carbon. Carbon is my central atom. Okay. Next, I'm going to do lone pairs of electrons. Well, carbon already has 2, 4, 6, 8, so carbon's happy, but each chlorine only has 2 right now, so I'm going to add 6 electrons to each chlorine. Okay. And then the last thing that I'm going to do once I'm done filling this out, now that everyone's happy, is I'm going to count the valence electrons again. I've got to only use 32, so let's make sure I did that. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, and I am good to go. The last thing for you to remember is that the Lewis dot diagram doesn't actually, this isn't how CCl4 actually exists. Instead, if you create it with a molecular model kit, you're going to have the carbon in the center, one chlorine up here, and then it actually creates a shape that looks like about that. In order for you to actually really understand it, make sure that you're playing around with the molecular model kits, but it looks like that. And then you have all the electrons around it. Okay, so make sure you draw it like this and not how I drew it up above. Okay, and that's it.